that we are going to concentrate in the Arduino exercise. Then we are going to use two controllers. One is ARM based controller, another one is the Atmel Atmega 328. Very first we are going to deal with the Arduino. Okay, so Arduino IDE is an open source hardware. Then it has variety of versions. The beauty of this is, if you learn Arduino, you know that idea is sufficient to do the program with the other variants. That is a major advantage. If you learn any one board how to access, the remaining yourself you can start write the program. Only the peripheral numbers you need to check with the help of the hardware, then you can start write your coding. Then why it is popular? It has a number of sensors readily available in the market. Simply we can buy and start interface these things. Okay, few of the things we will cover it in our lab session. Remaining, you try it by your own. Then regarding the power supply, you need to give 5-volt power supply. There are three ways. One is USB, another one is power jack, then this VIN and ground pin. So you need to apply plus 5 volt. In this power jack alone, we will apply the voltage in the range of 7 to 12 volt. Last class I have asked why I need to give 7 to 12 volt. Anyone found the answer? If not, please make note of it. Your regulator ICs, say example, here we have one regulator IC. If you take an example of this, if you compare this regulator IC with 7805, this is not exactly 7805. This is a little advanced regulator. Typically, if you take 7805 IC, for that IC, you have a 3 pins: input pin, ground, and output pin. In the output, irrespective of input voltage, you will receive the plus 5 volt. But input, you have certain range. Input, if you give exactly 5 volt, you won't get the output. Once you go and check the data sheet of the particular IC, then you will come to know the input voltage range is from 7 to certain voltage range. Say example 12 volt. At least I need to give plus volt higher than my output voltage. That is the idea behind that. Okay, that is the question I have asked. If you have found the answer, very good. But this is not exactly 7805. This is some other regulator IC, but it does the same action. Okay, then here this is my reset button. This is my USB to serial IC. Then this is the crystal oscillator, belongs to my communication IC. It will take care of my baud rate. Then this is my microcontroller. Then this is the question I have asked. What is ceramic resonator? Have you found what is ceramic resonator? Simply, the ceramic resonator is also a subset of your crystal oscillator. The ceramic resonator consists of two components. One is your crystal oscillator, another one is the capacitor. So whenever you find the crystal oscillator circuit, then find some ceramic capacitors associated with it. See, if you find this crystal oscillator, nearby you have some ceramic capacitors. But in the resonator, everything is inbuilt. Therefore, it is compact in size. So ceramic resonators consist of crystal oscillator as well as your inbuilt capacitor. So that is the difference of the ceramic resonator. Then, can you tell me what is the function of these pins? Can anyone type it in chat box? What is the function of these 14 pins? Hello? Else you can unmute and answer. What is the function of these 14 pins? Can anyone unmute yourself and answer? What is the function of these 14 pins? Hello? Is it my screen is visible? What is the function of these 14 pins? Hello?
Sir, input and output they are playing.
Digital input and output. Very good. So this is digital input and output pins. What about these 6 pins? What about these 6 pins? A0 to A5.
Analog input.
Analog.
Sairam?
Analog input pins. What about these pins? Reset, 3.3, 5 volt, ground and VIN. These pins are called as what? Power pins. Okay, so these are very important. So digital input and output, analog input and power pins. Okay, all the things we have discussed in the last class except one main thing. Please make note of it. Your Arduino IDE uses Atmega 328 is a microcontroller that we have seen in the last class. In that, you have the flash memory. The size of the flash memory is 32 kilobyte. Please make note of it. 32 kilobyte, out of which 0.5 kilobyte is used for boot loading program. Remaining size only user can access it. Okay, and also in addition to that, you have SRAM, that is static RAM of 2 kilobyte. Okay, all the memory size in kilobyte, as we discussed earlier in the theory portion, embedded program requires only less space. So here your memories are in kilobyte, not in megabyte. Okay, please make note of these 2 points. What is the size of your flash memory? What is the size of your static RAM? Okay, shall I move to the next slide? Shall I move to the next slide? Yes. So everything we have discussed, only few things are new to you in this class that I will stress and tell you. Okay. First one is your microcontroller that we have learned. Then this is USB port. Then is power connector. Then VIN and ground input pin and 5-volt power supply output pins. Then power on LED. Please make note of it. Our Arduino Uno board consists of 4 LEDs. The first LED with the label on. This is called as a power on LED. Please make note of it. That is the first LED. Okay. So whenever you plug your cable into the USB port, immediately power on LED will get turned on. Okay. Then followed by reset button. Then TXRD LED. TXRX means transmission and reception. Transmit or receive. Whenever you do serial communication, these two lights will give the indication that a particular access takes place in your board. These are the remaining 2 LEDs. So far we have seen 3 LEDs, power on LED, RX and TX LED. Okay. Then these are all digital pins. These are all analog pins. The final one is your onboard LED. This onboard LED connected it to the pin number 13 of your digital pin. What for this one? See, whenever you find any hardware, in that they will give some onboard LED. The purpose of the onboard LED is to test your hardware unit. Say example, if you are going and buying the hardware from the store, if you want to test this particular hardware unit, simply if you give the power supply to this board, immediately this onboard LED will get blinked, because by default they will load this blinking program into the IC for the testing purpose. If you power it, immediately LED will blink. If it not blinks, you have to program it once, then you can check it. Okay, 4 LEDs, one is for power on, then 2 LEDs for serial communication, and the 4th LED is your onboard LED connected in pin number 13. So if you want, take a screenshot of the whole content. Please take a screenshot of the whole content. This is the major hardware components available in this board. Whenever, if you want to recollect, you can refer this diagram and you can recollect the components what is available in this board. Okay. Then coding, very simple. Here we are going to use the embedded C. This particular structure is called as an Arduino sketch. Here by default you have a 2 function. One is void setup, another one is the void loop. In void setup, all the initialization coding we will write here. It will execute only once. In loop, the void loop is nothing but the infinite loop. So infinite time your program will start execute. What are all the coding? The main coding. For example, if you consider the embedded system program, all initialization pin mode, those things we will write it in the void setup. The remaining main program we must write it in the void loop, because 24/7 my embedded hardware need to work. Therefore, I need to write my main program in the void loop. Okay. I think with this you are clear about the things what we have discussed so far. Then we are going to see only few syntax what we have learned last class. Pin mode. What is the function of the pin mode? It is to configure your pin number as either input or output. What is the function of this syntax? It is used to configure your digital input output pins as either input or output. That means what? At a time I can access it in any one mode. What is the importance in this syntax? What I need to take care? The case sensitive. What are the things in capital letter? The output is capital letter. Then the M is capital letter. The remaining letters are in small letters. Okay. Then pin numbers. Pin numbers start from 0 to 13. I can type it over here. Okay. This is the very first syntax you have learned last class. Then, once you configure the pin mode, immediately we will pass some value into the pin. What is the possibilities available? Either logic high or logic low. The second syntax, what we have learned in the class, the second syntax is your digital write. It is very important. Please note down digital write pin number followed by the value. If you make it as a high, it will produce the logical voltages, logic high 1. That means logic 1, the equivalent DC output voltage is plus 5 volt. If you make it into low, it will produce the equivalent logic value as 0, that is equal to 0 volt. Okay? Since we are using the TTL logic, low is 0, high is 5 volt. That is regarding your digital write function. So with this, then delay, there are two functions. Against the inbuilt function, delay means, simple delay means if you pass any argument in that, it will consider as a millisecond value. So 1000 is nothing but 1 second. Microsecond is the second delay function. Whatever the value you will pass it over here, it will be considered as a microsecond. That's all. So I need to, now I am going to make the LED to blink. So this is your first exercise 5A, interfacing of LED with Arduino. On all the exercise, we will give you the problem statement. Go through the problem statement. Wherever you find the fill in the blanks, fill it. Okay, let me read the problem statement once. Interface an LED to digital port pin dash of Arduino. Here, since I am going to use the pin number 13, let me fill the filling blanks as 13. Okay, interface an LED to digital port pin 13 of Arduino and write a program to blink the LED. Okay, so first one is the exercise name, then problem statement. Then I need to go to the interfacing diagram. The interfacing diagram will give you the idea that what is the hardware setup I am going to interface with my exercise. Here we are going to use one LED and resistor. These things we are going to interface into our Arduino board in pin number 13. So whenever you start write your observation or record, if the pin number is exactly matches with the printed one, you can take it as the same, or else mark it by your own, what pin number you have used in your particular exercise. Okay, why I am instructing these things mean, at the end of the class we will show you how you need to upload your record content in the Google Classroom. At the time you need to follow these things. Therefore, please take care of these things. You have to write these things in your record content, then you need to upload it. Okay. Then flowchart is very, very important. Whenever you start write the program, if you refer your record, you will be having the flowchart. Go through the flowchart once, then prepare your algorithm by your own. We will give you some algorithm. Then you try to write by your own, whatever the algorithm you can set up. Then convert it into your program. So what is the algorithm here? In setup, I need to configure the digital port pin as output. So configure 13th pin as output. That's all. Then in loop, in infinite loop, what I need to do? I need to make the pin to high. Then I need to introduce the delay, followed by I need to make the same pin to low, then delay. Can anyone assist me? What is the equivalent coding I need to write it? Can anyone type it in chat box? How I can configure 13th pin as output? Can anyone type it in chat box? Hello? Void setup, what we need to write? How you will configure 13th pin as output? Hello?
Using pin mode.
Hello? Pin mode, pin mode, pin mode,
Sir, pin
the
mode of
particular
13
pin
comma
mode,
output. Honest
output.
wallet.
See, pin mode 13 comma output. Very good. That's all. Void setup is over. In void loop, what we need to write? What we need to write? How we will make the 13th pin to logic high? Can anyone type it in chat box? How we will write?
Sir, digital write of 13 comma high.
Very good. Digital write off 13 comma high. Then how will introduce delay 1 second? Is simple delay of 1000. That's all. Program portion is over. Now I need to type the same coding in the Tinkercad platform. So last class we did the blinking. The same thing we are going to recollect. Here we are going to do three things. First, onboard LED blinking, immediately external LED blinking. Then we will show you how we will make the two LEDs to blink in alternate fashion. Okay, let me come to the Tinkercad classroom. How to get into the Tinkercad classroom? Very simple. Go to your Google Classroom. You will find this message. Simply click this link www.tinkercad.com/join class. In that, you need to type your class code. Simply copy the class code. Simply copy the class code and paste it, followed by your nickname. Here I am going to use my nickname. You need to, in your case, you need to use your corresponding nickname to log in. Okay, that's all. Then you will get the dashboard of your Tinkercad software. By default, it will show 3D design. Change it into circuits. Change it into circuits. Then create new circuit. Then create new circuit. That's all. I repeat once again. Go to Google Classroom. Click your Tinkercad link. Copy your class code. Then type your nickname. That's all. Then this is the new page. You will get it. Here, what you are going to do means, please see, whenever you start do the exercise, please take the same exercise name. That's the name of your project. Okay. So here, simply I am going to take this as experiment number 5A, interfacing of LED with Arduino. Okay. Arduino. This is your name of your exercise. Then I am going to start the exercise. See, let me zoom the screen little, thereby you can view it easily. Wait a minute. Is it Tinkercad software is visible, ma'am? Hello, ma'am.
Sir.
Okay, ma'am. Okay, ma'am. See here in the component list, select all. Select all. Point number 1, go to component list, select all. Then come down, you will find a number of options available here. In that, first I am going to fetch my controller. Okay. I'm able to zoom the window. See, in the microcontroller option, you will find your Arduino Uno. How to select the Arduino Uno? Click Arduino Uno, then drag and drop it in your workspace. That's all. Very simple. Okay? Very simple. In this way, you can drag and drop your hardware component. Then go to code option. Click code. There you will find n number of options. In that you find text. There are 3 options available over here. Blocks plus text, then text. In that click text, followed by continue. That's all. Here, by default, you are having blinking program here. So if you want to practice, type the coding by your own. Don't take the previous codings. See, it is case sensitive. As already told you. First, I am going to write the things. What are things we need to declare in the void setup? Pin mode 13 comma output. Pin mode 13 comma output. then semicolon. If you want to comment the line, what comment I can give? Make 13th pin as output. Make 13th pin as output. That's all. In void loop, what we need to do? We need to make the pin to high, logic high. So digital write off 13 comma high. That's all. What is the comment relevant to this? Make 13 pin as high. Make 13 pin as high. That's all. Then delay. Introduce the delay. Delay for 1 second. Therefore, I am going to take 1000. So here simply delay for 1 second. That's all. Then what else? The remaining things are similar to this. Let me copy and paste it over here. Simply you can select the content. Right click and copy. It is a one option, or else Control C and Control V. Okay, Control C to copy the content. Control V is to paste the content. So here I am going to make it as logic low. That's all. Then delay. See, say example, if you are writing the correct coding and if you click start simulation, it will take some time to execute. Then here simulation time will start run. Once you observe this, there is no error in your code. If you want to view your hardware component clearly, please click the code option once again. It will close your window. Then come here. Here you have an icon called zoom to fit. Click the icon once, it will fit into the entire window. That's all. See, I told you there are 4 LEDs available. This is your power on LED. Continuously it will be in on. Then TXRX, while you do the program only, it will get blinked. Then blinking program, if you make the 13th LED, that is onboard LED. If you write the program to this LED, then only it will work. Okay. See, I am going to stop the simulation. Power on LED is also off. Blinking LED is also off. See, my USB cable is unplugged. Please observe the animation. Whenever I give the start simulation, this USB cable will be plugged gently. Immediately power on LED will get turned on. Then your blinking LED will take place. Please observe the animation slowly. Plugged, power on LED is on, LED blinking is on. Is it okay? Is it clear for everyone? Yes. And now, what about the today's task? What is the new thing we are going to do here? See, what we have did there, we created a square waveform. On for some time, off for some time. But in this example, it is declared as a 500 millisecond. But in our case, we make it as 1000 millisecond. That is 1 second. Okay. On means LED will get turned on. After some time, you are going to off your LED. Okay. So this is a pattern you have generated as an output that creates your output in your LED. Then, what is the next exercise? I am going to interface one additional LED in the external component. I am going to wire it into the pin number 13. Then I am going to use the same coding to make the external LED to blink. So how we will do that? Come back to the simulation portion again. How we will execute it? For that we need breadboard first, isn't it? So for that what I am going to do, click component list. Wait a minute. See, this is your component list. There I am going to fetch few components. What are all things necessary for our upcoming exercise? So first one is the breadboard. Keep the breadboard. So simply select the breadboard and place it in your workplace. Okay. Then what are the other components we need? Can you assist me to make the external LED to blink? What are all the hardware setups I need? I chosen the microcontroller and breadboard. What are all the other components we need? Can anyone tell or unmute yourself and tell what are the other components we need?
sir.
LED. Where we will find the LED? Simply go to output component. See, output component. Here you will find the LED. Then what else? I can't connect the LED straight away into my microcontroller.
A resistor.
It will damage the LED. Those theory components we will discuss later. After completion of this exercise, I will show you. So here I am going to take one more component as my resistor. Okay. Why? See, the name of the resistor is the current limiting resistor. Typically, we will keep the value of the resistor is in 220 ohm or 330 ohm. I will tell you after this project output. Once you receive, we will go back there and we will learn the theory component. Okay. Now, see, if I want to move the whole setup, simply I can move it like this. How I can move it? See, you keep your cursor anywhere else in your workspace and left click and move the component. Wherever you want, you can move and place it. Okay. Then I need how I can do the connections. Very simple. First, I need to power my breadboard. From where I can fetch my connecting wires. You no need to go anywhere and fetch the connecting wires. Simply get your cursor nearby your terminals available in the hardware unit. See, this is my Arduino board. See, if I go nearby to my board, it shows the name of the particular pin. See, 5 volt, ground, A0, A1. Likewise, it will give the labeling of the particular pin. For very first, what I am going to do is I am going to power this breadboard. How I am going to power? Take 5 volt power supply. See how I am going to draw. See, it is very much similar to your multi-sim and what is the one, another thing we have used in the lab? Linux-based software we have used, QCS. In all the software, we will do like this only. See, simply take your connecting wire. Wherever you want to make the turn, simply click left click and move. If you make a left click, the wire will break in that position. Then you can keep on move the wire. Then again one left click and connect it in the breadboard. So since it's a positive wire, I'm going to select the color as a red. See, there are number of colors available in this software. I am going to choose red as my required color right now. Connected. Then ground. Ground, I am going to take it. And I'm going to connect it over here. What color I can choose it for the ground? Black. That's all. That way we have powered the breadboard first. See, if I want to move the wire, you can move it anywhere else in the workspace. Make it into 90 degree. 90 degree means both horizontal line and vertical line will appear in your window. Thereby you will get it 90 degree exactly. That's all. Then come to the resistor and LED. LED, you have multi-colors. You can choose any colors available in this menu. Let me keep it as a red color as a default. If you want to change it as green, you can change it as a green. Those options available. Where it is available, click the LED, immediately one menu bar will open. There you will find the drop-down option. There you can choose the color of your LED, yellow, green, like that. You can choose any one color. Let me keep it at a green in this point of time. Then select the LED and bring it into breadboard. Okay. How many terminals are there in the LED? One is the cathode, another one is the anode terminal. So what I am going to do, cathode terminal, straight away I am going to connect it into ground. Cathode terminal, since it's a cathode terminal, I am going to make it as a black color, as a wire color. Then this is my resistor. Orientation of the component. If you want to rotate this resistor, how you can rotate? See, here you have icon to rotate your component. For single click, it will rotate into 45 degree. Okay, so 45 degree, it will get rotated. Now I am going to make it to the horizontal wise. Then I am going to connect it over here. That's all. How to give the value of the resistor? Simply you can type it over here. Let me type it as a 220 ohm. So default it will show kilo ohm. Go to ohm and select it as a 220 ohm. That's all. In this way we have connected our LED and resistor. Where I need to connect the other end of the resistor, I need to connect it into the pin number 13. So take another wire and connect it here. That's all. The hardware setup is over. Setup is over. If you want to change the color of the wire into any required color, you can give it. That's all. Now I am going to simulate and check the output. Click start simulation. See, now my LED gives blinks. Is it clear for everyone? Do you have any doubts so far? Please interrupt me. Else I will continue my presentation.
Sir,
Do you have any doubt? Please type in the chat box. Hello,
sir,
ma'am.
one doubt, sir.
Solunga.
Sir,
Yes.
how to rotate that resistor, sir?
Very simple. See, select the resistor. Okay. Then come to this. See, hello. Can you view the shortcut icons available below this Tinkercad icon? Rotate. Hello.
Sir?
Can you view? The first icon is rotate. Second one is delete.
Sir,
This is in that. See, this is undo. These are all label. This is mirror. The remaining icons I will tell you later. At right point of view, only concentrate on the rotate. See, if you simply click rotate, the component will get rotated. Can you view it?
Okay, sir.
That's all. The orientation, whatever the orientation you require, you can do it in that way. Then you can start do the connections. Okay.
Okay, sir.
Code, same code we have used. So I didn't modify anything. And one more thing, whenever I am running the simulation, if I want to do any correction in my hardware setup, I can't do it. Say example, I am going to select the component and I am going to try to rotate. See, if I rotate means immediately it will making my simulations to stop and it will starts rotate. But if you do some other modifications, it won't allow. Why it won't allow means it insists you to stop the simulation and then you do the hardware connection. Okay. See, it is also a best practice. Whenever you do any hardware connection, unplug your Arduino board, then you start give the connection. Okay. Shall I continue? Shall I continue? Yes. Now we'll come to the little theory portion. This way, how to identify the anode and cathode terminal. In Tinkercad, it will give you the polarity, it will give you the labeling, but physically, if you buy the component, it won't say I am as an anode terminal, I am as a cathode terminal, likewise, it won't tell. So this is your symbol, this is your physical component. The longer lead will give the indication of your anode terminal. Then shorter lead means it is cathode. This is the one notation how to identify your anode and cathode. But whenever if you want to solder this component into your breadboard as a PCB, you will make the LED terminals to same length. You will cut the remaining portions, then you will solder these two terminals. In that condition, say example, this is my LED with equal length. Someone made the terminals to cut and they used it into some other hardware components, some other hardware exercise. If that is the case, how you will find the anode and cathode? For that, see, this is the bottom view of your LED. Your bottom view is not a full circle. It is not a full circle. One side is flat surface. See, here also it is given the notation flat surface. So the nearer to the flat surface, whatever the terminal available is considered as cathode. Please make note of this. Let me erase these contents from the slide. Okay. Please make note. Please take a screenshot. By turning your LED to down, and this is the bottom view of your LED. The flat surface, nearer to the flat surface, what is the terminal available is called as a cathode. Another one is anode. You no need to memorize both the concept. Take only one concept. Okay. Flat surface cathode, long terminal anode. Enough. Okay. Then how to calculate the current limiting resistor value? Whenever you buy the LED, if you find the data sheet, there are different specifications available for the LED. The first one is the size of diameter of the LED. See here it is 8 mm, here it is 5 mm. Even 3 mm LED is also available. Okay. Then the second specification is color of the LED. Based on the color of the LED, forward voltage drop will vary. Okay, size of the LED, point number one, then color of the LED. These two will decide what is the forward voltage required across this LED to make your LED to light. For that voltage they will give in their data sheet. Then you know what is your input voltage. In our case, if you consider this input voltage as a 5 volt, if I straight away I give 5 volt to my LED, it will draw enormous current and LED will get damaged. To avoid that, I need to introduce one current limit resistor in series with my LED. How to calculate the value of the LED? The calculation is given here. How to calculate the value of the resistor? Simply Ohm's law, R is equal to V by I. V is nothing but voltage drop across this resistor. How to calculate voltage drop across the resistor? V in input voltage, you know. What is the forward voltage drop? I need to observe from the table and subtract these two. Then forward current. This is also another specification given in your data sheet. Forward voltage of the corresponding LED and current, both the things they will give. Take these two parameters from the data sheet and substitute. Vs is the user defined value. From that you can calculate your current limiting resistor value, then you put it into your corresponding circuit. Okay, this is the calculation. Here we consider 18 milliamps is the current and 1.8 voltage is the forward voltage and Vs is 5 volt. Typically it gives 183 ohm, but 183 ohm resistor is not available in the market. You may get 200 ohm resistor or 220 ohm resistor. The closer to this is 220 ohm. It is a single resistor. So typically we will use 220 ohm resistor. In certain cases we will use 330 ohm resistor. Okay, that's all regarding the theory portion. Now additional experiments. Please help me. Please go through the first exercise. Blink an LED connected in pin number 13 with on time of 5 seconds, off time of 2 seconds. Try to modify our previous coding. What are all the change in code I need to do? Please help me. Please type it in chat box. Please type it in chat box. Please type it in chat box. Take down the question once. Take down the question once and try to give the solution. On time 5 seconds, off time 2 seconds. How I can do? Can anyone unmute yourself and answer? Please make it fast. On time 5 seconds, off time 2 seconds. How we can make it? Hello? Hello? Can anyone
Sir, on time
unmute
delay.
yourself and answer? Yes, very good. Delay 5,000, delay 2,000. In which case it is 5,000 and which case it is 2,000?
That in height.
See?
For high, it is 5,000.
Very good, very good. For high it is 5,000. Low it is 2,000. Is it clear? Is it okay? Shall we start execute? Let me do one thing. Let me do one thing. Let me give some typing error. Say example, let me make the spelling mistake. DLAY. Simply I am going to type like this and I am going to start simulate. It gives the error message. If you see the error window, it will be available in the bottom of your main program window. Here, see, DLY was not declared in this code. That means this is not an inbuilt function. You can't use it. Or else it is a user defined. We must declare the variable in any one line of your program. We did declare any variable name called DLAY. It suggests the alternative also. Please, how clever the software is. It suggested to alternative code as a delay. Okay, so simply you can take the solution as a delay. Simply you can copy this and paste it in your code. Okay, sorry, it takes the whole thing. Let me change the delay like this. Now you start simulate. Likewise, if you do any mistake, okay, the debugging is easily you can do it with the help of the software. Now I am going to start simulate it and I am going to observe the change in output. What is the change in output? Now I have increased the on time for 5 seconds, off time for 2 seconds. Okay? Can you observe the change in output? That's all. So this is the beauty of your program. If you have any microcontroller unit, whatever the hardware change you require, within no time you can do it. If it is fully relies on hardware setup, you have to change your hardware component. You have to design the calculation. Say example, resistant capacitor value you need to change, then only you will achieve the change in output. But it is a programmable one. Simply by changing the 1 or 2 lines in your program, you can do the wonders. Okay. Then the second additional experiment, blink and alternate LEDs connected in pin number 10 and 12. Please observe this animation. Please observe this animation 10, 12, 10, 12, 10, 12. You can give same delay as 1 second between this toggle condition. Can anyone assist me how I can start do this exercise? How many output devices I need to interface? Can anyone view this animation in the slide? 10 and 12? Can anyone view the animation? I hope everyone can view this.
Yes, sir.
Very good. Okay, now you come to the hardware component. I want to add one more LED. How I can do it? See, here I am going. See the first option. I need to take the component list. Then I need to fetch the resistor and fetch LED and resistors, or else close this window. Close this window. Okay. Select the component. Okay. Select the component. Control C, Control V. It will give the first component. Can anyone see this? How I arrived the new component? How I have arrived new component? See, select the component. Control C, Control V. New component. That's all. That's all. Okay. Then I need one more resistor. Make same function. Control C, Control V. That's all. Now, what are the hardware change I want to do? 10 and 12. Okay, 10 and 12. Simply drag the wire and connect it into 12. Let me keep it into 10 this. That's all. First LED 10, second LED 12. Second LED 12. That's all. Hardware setup over. Hardware setup over. Now you assist me. And one more connection is left. Can anyone tell? What is that? Only one connection, hardware connection is left. Can anyone assist me? Hello?
Cathode.
Yes, very good. Cathode terminal, I need to connect it into ground. Black. That's all. Now come to the coding part. In void setup, what are the things I need to do? Can anyone unmute yourself and assist me to change the modification, help me to modify the program? What are the changes I need to do? Pin mode. What is the pin number in our case? Hello? What is the pin number in our case?
Sir.
10. 10. Very good. Pin 10. Pin number 10. Then same coding we are going to use it. So therefore, let me copy the pin number. Second as a 12. Then that's all. Then what else we need to do it in the loop program? What are the things we need to do? Tell me. First pin number 10, I am going to make it as a high. Okay. Pin number 10, I am going to make it as a high. Then, during that time, what is the condition of pin number 12? Can anyone tell me what is the condition of pin number 12? If you observe the animation, you can tell. At any point of time, only one LED glows. So whenever LED 10 glows, what about the condition of 12? It is in off state. Very good. How I can make it into off state? Tell me. How I can make it into off state? Digital write-off, pin number 12 comma low. That's all. Pin number 12 comma low. Followed by. Let me give the delay as of 1 second. Okay, let me give the delay as 1 second. Then here, whatever the LED you made it into high, the same LED I need to turn off immediately after some time, isn't it? So what I need to do here? Here I'm going to do the reverse action. Now I'm going to make pin number 10 to low. Pin number 10 to low. Then 12 to high. That's all. 12 to high. HIGH. And I'm going to give the same deal. 12 to high. Is it clear for everyone? Please observe the coding. Please observe the coding. That's all. So, two output, pin mode 10 comma output, 12 comma output, then first LED high, at that time second LED is in off state, then give some time delay, then second LED, first LED off, second LED on. If you want to have the program means, let me copy it in the chat box also. If you want, you can take it later. Sorry. Yes. Now you come back here. Give start simulation. How to close the simulation window? Can anyone tell? Now I am unable to view the output. Can anyone help me? How I can check the hardware output? Hello? Hello, what I have to do?
Press code, sir.
Press code window. Click code. That's all. Now you check. Now you check. You got the same output. Alternate fashion, isn't it? First LED on, second LED off. Second LED on, first LED off. Okay? So in this way, you can do wonders. These are all additional experiments. Wherever I spell it as additional experiment, those things is for additional input only. But in the examination point of view, we will ask these kind of questions. But your exact experiment is blinking an LED in pin number 13. This is your exact exercise. This you must do. Remaining things, whenever you find free time, try to do it. Okay, then this is your task. Please take a screenshot of the question. Please take the screenshot of the question. Here we gave 4 LEDs. The 4 LEDs need to blink in this alternate fashion. Please observe the output. Please observe the output once again. Please observe the output. First LED on. At the time, remaining LEDs in off state. Then after some time, first LED off, second LED is on. After some time, second LED off, third LED on. After same time delay, third LED off, fourth LED on. Then the cycle has to repeat in the same manner. Means fourth LED off, immediately first LED on. Likewise, you need to do the program. Here the thing is that you should not declare. You should not declare all the pins as an individual pin mode, input output. If you keep on write the coding, it will end up with n number of lines. How to minimize the line? Please think it over. What kind of loop you can use it? You may study a number of C structures in your C program. Try to use any one of the C structure here. I will give you the only one hint. Once you tell, if you note down the question, I will give you the hint. Then we will go to the second exercise. This is the task 1. Please take the screenshot of the question. Try to implement it. This kind of questions only comes in the examination. Okay. Shall I give the hint? Here delay is 500 millisecond. Try to implement the same millisecond. Okay. What is the hint? I mean that, see, here, if I keep on declare 4 pins, here I need to write 4 lines, then he will end up with n number of lines. If I give 100 LEDs to blink, it is not possible to write that much lines. It will consume your memory space. How to minimize it? I will give you only one hint. Please observe here. Pin mode 10, output. No longer I need to keep this particular argument as a only number. I can declare any one variable. I can give any variable name also. For that, just before that line, I need to declare the variable name. Say example, int I. Likewise, I need to declare the variable name. Then I can use the variable as I. Using this hint, try to execute the program. Once you complete it, post it in your classroom, we will check it. Okay? This is the hint behind that. I know it is not all the time I need to mention the pin number exactly. I can declare any one variable like this. How to assign the variable name? Think it yourself. Okay? How many output pins required for our project, for your task? Can anyone unmute and tell how many hardware output pins required for your project? How many output pins required? Hello? How many output pins required? Hello?
4, sir.
4. Okay. How to
4,
write the
sir.
program? Think it yourself and do it. Okay. Then switches. Switch interface. Switch interface. Switch is the input device or output device? Quick. Switch is the input device or output device? Anyone unmute yourself and answer?
They are out as input pins, sir.
Hello, sir.
They are out as input pins.
Very good. Input device. See, plenty of switches available in the market. Whenever you find the time to do the project, choose the appropriate switch from the market. Okay. Here we are going to use only few switches, dip switch, slide switch, or push buttons. Beyond that, it is not available in our Tinkercad software. But practically, n number of switches available. But all the switches will do only these 2 actions. See, here I am showing one dip switch. The internal component of the dip switch is like this. You have a slider option. If you slide the switch, this mechanical component move from left to right. Thereby, my moving contact or sliding contact will get close with the fixed contact. See, whenever you draw the symbol, you will find 2 things, this one and this one. Isn't it? So, this lever is similar to our symbol, isn't it? So whenever you make your slide to move from left to right, that is from off position to on position, your circuit will get close. My switch will come across only 2 states. One is open state, another one is closed state. Okay. So how to read this change in state that we are going to do? Check it now. How you did in a microcontroller, in the same way only we are going to do it. This is an input component, simple input device. With the help of that, we are going to do few exercise. Okay. Now you come to the syntax. How to read? See in our Arduino, the syntax are very simple. It is very much similar to our English language. In which way we pronounce, in the same way they will give the syntax. Read action. From where we are going to read? From digital pin. That's why they added the first argument as a first name as a digital, then read, then followed by pin number. If you compare with the digital write function, in this argument we passed 2 things. One is the pin value followed by the value. But while reading the external environment, we are going to simply read the external environment. You are not going to do the logical change by your program because my hardware setup will take care of the logical change. Therefore, I need to mention only the pin number. Please make a note of this syntax. Digital read or capital letter. In the pin number, I need to mention the digital input output pins. Here we have given an example how we can use this particular syntax means. Say example, I am going to connect the switch in pin number 10 means digital read of 10. I am going to call this function. At the end of the function, it will return any one value. What is the value it will return? It will return either 1 or 0 or true or false, isn't it? Digital means I will come across only two states, either logic high or logic low or true or false, isn't it? What I needed to do, I need to store the particular value into any one variable. Then, by checking the variable status, I can make my logical change in my hardware setup. That you familiar with that. You are using if function, you can start do this. Okay. Please make note of the syntax. Digital read or capital letter. In the argument, I need to pass only the digital pin number start from 0 to 13. Okay. And also take down the example. Here we have taken the pin number 10 as an input. Okay, very good. Now this is the overview. Whenever I am using any peripheral pin as a GPIO mode, point number 1, I need to mention the pin mode. I need to mention the pin mode using the command name called pin mode. Then the pin may be accessed as an input or output. Input means I need to read the status. Output means we need to write something into that pin. Okay. So write means simple typical example LED. We have to write the syntax called digital write of pin number comma high or low. Then read means simply switch. The switch may give logical high or low. Okay. The syntax corresponding to that is digital read of pin number. Okay. Now I am going to show you a simple diagram. The first diagram is in off state, second diagram is in on state. Okay. Can anyone give the answer? Whenever my switch is in off state, see here I have connected with VCC. That means consider it as a 5 volt. Okay, consider it as 5 volt. Whenever my switch is in off state, what is the voltage level or logic I will receive in this pin? Can anyone type it in chat box? Quick. Whenever I make switches in off state, what logic I will receive in this pin? Hello?
Sir, they are typing 0 ground.
Okay, 0. That is the expected answer. Okay. Then what logic you will receive in this case whenever I close the switch? Whenever I close the switch, what kind
Logic
of
1.
logic 1? Any other answer for these two diagram? Any other answer? Anyone have the controversy in this? No. Okay, let me tell. You gave two answers. Whenever I made the switch to open, it is logic low. Whenever I close the switch, logic high. Out of these two answers, one is wrong. This is not logic low. From where it will receive logic low? Whenever my switch is in open state, see, this is not connected anywhere in my circuit. But here, if I close the switch, simply VCC will come to this pin. But here, it is not in logic low or logic high. It will be in floating state. Please make note of it. Floating state. It will not be in either 0 or high. It will be in floating state. Okay? How to avoid the floating state? How to avoid the floating state? For that, we are going to use one configuration called pull down configuration. We have two things, but here in today's class, I am going to show you only pull down configuration. See, pull down configuration is very simple. This input is nothing but port pin of your Arduino. Let me consider I have connected this with my Arduino Uno. Let me consider this is my Arduino pin. So I have connected input terminal of my Arduino pin. Now I have connected one resistor, high value of resistor. Please note down the value of resistor. Typically it is in 10 kilo ohm. Now I am going to pull down this pin to logic low. That means ground. Therefore, the name of the resistor is called as pull down resistor. In this condition, if my switch is in off state, I will receive logic 0. How we will receive, sir? How we will receive? See, this is your current path. This is your current path. Ground to this pin. What is the logic available here? 0 volt. Therefore, I will receive logic 0. But if I make this switch to on, what logic I will receive over here? Logic high. But in this condition, I have a two current path. This is one current path. This is the another current path. Then why logic high is dominant? Because logic high circuit doesn't have any resistor. But logic low consists of high value of resistor. Therefore, logic high is the dominant one. Therefore, I will receive logic high in this pin. In the same way, we are going to interface the switch. We are going to read the switch. Correspondingly, we are going to make the output. If anyone want to take down this diagram, please take screenshot of this. This configuration is called as an pull down resistor. If anyone interested, please browse what is pull up resistor. What is pull up resistor configuration? There are two types of configuration available. We have shown only pull down resistor. Who are interested to learn this, go and browse pull up configuration. Okay, pull down means making the pin to logic low permanently. Whenever switch logic changes, it will give logic high. Pull up means making the same pin permanently with logic high. That you refer and read it. Okay. Take down the name of the second exercise. Interfacing of switch with Arduino. The problem statement: interface a switch to digital port pin of Arduino. Write a program to read a status of a switch, and only when the switch is in on, turn on the LED. So on condition they have given. Then what about the off state? That means whenever my switch is in off state, I need to make the LED to off. That is indirectly given. You need to understand the question. Okay. So read the status of the switch. Whenever my switch is in on state, make the LED to on. Come to the hardware setup. This is my hardware setup. So here, wait a minute. Here we are going to use two pins in our Arduino board. One is to interface the LED. Another one is to interface the switch. Can anyone tell what kind of configuration we have used in this resistor? Whether it is a pull down or pull up? Can anyone type it in chat box? What configuration it is? The whole configuration. It is a hello. Quick. Can anyone type it in chat box or unmute yourself and answer? Hello. Am I audible?
Sir, you're audible, but nobody is typing.
Okay, no
Pull
issue.
down resistor.
Pull
They're
down configuration. Yes, pull down configuration, no issue. Come, see, this is our interfacing diagram. Here we are going to declare the pin numbers. See, I am going to connect my pin LED in pin number 13, and the switch I am going to connect it in pin number 10. See, in your observation, see, in your record content also, you need to write it like this. You need to draw the diagram. Then you need to write the pin number side by this. Okay. So once you mark the pin number, then only it is easier to write the coding. Okay. Now you come to the flow chart. So flow chart is very simple. Configure input pin, configure output pin, then read the status of the switch. If my switch is in high state, make the LED to on. Else, go and check the read status, when check for the second press. If again second time if anyone presses the switch to on, then you want to make the light. Likewise, whenever it gets false statement, false means immediately go and check it. Yes means make the LED to on, then you go back to your loop. Okay, so likewise I need to write the coding. First we will break the setup into first. I am going to give the algorithm. First I am going to configure the pin number 10 as input, 13 as output. Then hereafter, whenever you declare any output devices in void setup, you make the output device into off state. How you can make it into off state? Here I am going to make turn off the LED connected in 13th pin. That means the output component always in void setup, I need to make the components to be in off state. Why, I will tell you the reason later. Now can anyone assist me? What is the equivalent coding I need to write it? Please quick. What is the equivalent coding corresponding to configure pin number 10 as output? Can anyone assist me? What is the equivalent coding of this? What is the equivalent coding for this? What is the equivalent coding for this line? Please quick. Hello? Hello?
Sir, pin mode of 10 comma input.
Very good. Pin mode of 10 comma input. What about the second one? Very similar. 13 comma output. Why it is output? Why it is output? Since I have connected LED, it must be in output mode. Why it is input? Since I have connected switch, it must be in a input mode. What about the last line? Very simple. Digital write off the pin number 13 comma low. That's all. In loop program, what I need to do? Simply, I need to read the status of the switch pin number 10. Then I need to check for logic high. Whenever I close the switch, I will get logic high. Whenever my switch is in off state, I will receive logic low. So if my switch is in on state, make the LED to on. Else, make the LED to off. That's all. What is the equivalent coding? Read the pin number, store it into any one variable, then check for the condition. If condition satisfies, make the LED to high, else turn off the LED. That's all. Okay. How to execute this? How to execute this? Come back here. Come back here. See here. How to take the new exercise? How to take the new exercise? Click the Tinkercad icon. Click the Tinkercad icon. Then you can go back to your previous menu. Okay. Then from there you can choose the new circuit diagram. Okay. If I want to make the copy of this same circuit, click the gear icon and click duplicate. I repeat once again. Click gear icon, click gear icon, click gear icon and click duplicate. If you click duplicate, immediately the same circuit setup, you will get it once again. There, whatever the modification you want, that alone we will do it, then we will finish the exercise. Okay. Hardly 5 minutes it will take. Please observe. After that, I will give you one important instruction. Don't leave the session early. Okay. Let me take the exercise name, experiment name. Let me rename the exercise. Interfacing of the switch with Arduino. What are all the pin numbers? Pin number 10, I need to connect the switch. And pin number 13, I need to connect LED. So LED, simply I am going to make a small change in the hardware setup. Simply I am going to change the pin number. That's all. Now, the new hardware setup I need to receive. That is my switch. Where my switch is available, it is up. See, whenever you find the all component, in that if you go down in the input menu, will find the switch. Let me take the simple slide switch. See, this is 3-terminal switch. This is my common terminal. These two are the output terminals. Okay. If I slide the switch from left to right, these two terminals will be in contact. That means common and terminal 2. In this position, these two terminals will be in contact. What we are going to do is, we are going to use these two terminals. Okay. I am going to left free of this terminal. Don't bother about the third terminal. I am going to delete this LED. Simply take the switch, and keep it over here. If you refer your circuit diagram, how we need to connect how we need to make the connection. See, one end of the switch must be connected in logic 5, another end must be connected into the 10 kilo ohm resistor, and we have to make it into ground. Then same common terminal I need to connect it into my Arduino pin. Come back here, take the resistor, but the value of the resistor here, it is 10 kilo ohm. Okay, the value of the resistor here is 10 kilo ohm. How to change the value of the resistor? Simply double click over the resistor. Simply double click here. Wait a minute. Yes. Yes, 10 kilo ohm. Make it into 10 kilo ohm. That's all. Now bring the resistor here. So one end of the resistor must be connected into logic high. That's all. Then common terminal. These two are the common terminal. From where I need to connect it into pin number 10. So take the wire. Wait a minute. Then see here, this end I am going to connect it to the switch. Another end is the common terminal. Sorry. We'll do one thing. We will connect this as a high. Yes, see, one end of the terminal I have connected into the 5 volt. Then another end of the switch is common for this Arduino pin as well as your resistor. Then other end of the resistor I need to connect it into logic low. That's all. So only these two terminal we have used. So by default, it will give logic low into the pin. If you make the switch to close, it will give logic high. If anyone want to note down this, please take a screenshot of this. Okay. Now you come to the code portion. In code portion, what are all things I need to do? First one, pin number 10, I am going to configure it as an input terminal. Input. Pin number 10 as input. That's all. Then pin number 13 as output. No change in that. Then, as I told you already, by default, I need to make my hardware pin into logic low. Therefore, I am going to make pin number 13 into low. Pin number 13 into low. That's all. Now in void loop, what I need to do? We will delete the remaining contents. We will type newly. Let me assign the variable name as int SW, followed by I am going to read the status of the 10th pin. So digital read of pin number 10. That's all. Digital read of pin number 10. If my 10th pin logic is equal to high, what I need to do? Can anyone type it in the chat box? In if portion, what I need to do? In else portion, what I need to do? Can anyone assist me? Can anyone assist me? Simply, I need to read the status from the pin number 10. If it is high, what I want to do? Hello? Can anyone assist me? What I need to write it here? High means what I need to write? I need to make it as logic high. Logic high, I can represent in this way also. If simply pass 1, it will give the logic high. Logic low means the same command, digital write of same pin number. Instead of 1, I can give it into 0. That's all. So now we are going to check the hardware output. Let me start simulate this one. Close the code window. Now, initially my LED is in off state. If I turn on the switch, the LED is on. See? Can anyone view the output now? Can anyone view the output? See? This is my off state. If I turn on this is my off state. My LED is off. Now I am going to turn on the switch. LED is on. Is it okay? Do you have a doubt so far? Please interrupt me. Else I will give you one instruction. With that we will conclude. Okay? Off state, LED off. On state, LED on. Is it okay? Yes. See, I will tell you the procedure, then you can leave. See how you can submit your assignment, your lab work means, we will send you one Google form with the title of your experiment. There you need to do few things. Point number 1, you need to see, usually we will give some prerequisite question in your lab component. Those prerequisite questions here available in the objective type question. First you need to fill all the objective question. You need to answer these questions. Followed by, in second section, you need to paste your Tinkercad URL link. How you can paste the link? How you can paste the link? Consider this is my exercise. I want to share this output to my teacher means, go to share icon. See, in the right corner, you will find the share menu. Click share. In the invite people, click invite people icon. Then copy the URL simply. Copy the URL and paste it in your Google Sheet. Okay? How to get the URL link? Go to your exercise, share. There you will find invite people. Click the menu invite people. Copy the URL link. That's all. Then you can paste it in your Google form. And the last one, upload your record content. See, this must be in a PDF format. That too less than 10 MB. Okay. What content you need to send? We will send you the record content like this to you. Write all the content in a gentle paper. Take A4 sheet or else take any one good notebook. Write the content as like in our lab procedure. Left hand side interfacing diagram. Then right hand side this content you need to write. Fill in the blanks. Then followed by you need to write the coding portion. What is the program you have used and the corresponding commands. Then result. Once you finish this, scan the document, make it into PDF format, attach it over here. That's all. Okay. Do you have any doubt? You can interrupt and ask. Hello? Hello?
No doubt, sir.
Okay, that's all. Those who are completed can leave. If you want to take down these procedures, check your recorded video available in the Google